So far this morning we've had a look at the fibre technology and some of the latest cable technology coming out of Europe, the FlexTube. Now we're going to turn our attention to some more local innovations, some cable products that we've developed locally for local customers. We're in quite a fortunate position really. Prysmian in Australia not only has the resource of our European colleagues to bring products like FlexTube over, but we also have a type testing facility, R&D centre, based in our telecom plant in Dee Why. So there we can develop completely new products or improve upon our current range and really tailor them to the current market, the Australian environmental conditions, so we can answer the needs of our customers locally. So when we think about product development, certainly here in Australia, we're more aware that as a cable supplier, we've got quite a small slice of the pie in terms of the total cost to build a fibre to the home network. So this pie chart is giving you the distribution of the different costs. It's taken from a snapshot from some data from our European colleagues. And at 4%, yeah, we're quite a small slice of the pie, but our products have the ability to impact the two largest sections, installation costs and the civil works. And it's things like FlexTube that we think can help to bring down some of those huge costs in the way that people manage and implement their networks. So never has this been more the case than with our NBN developments. So when we took on the NBN products, we really had that pie chart in mind when we were looking at developing those products for the NBN. So Prysmian Cables has the majority of the underground ribbon cable that we supply to NBN. And those products are on our display board here. And originally, we inherited some ribbon products from our colleagues in the US. We started to distribute the version 1 ribbon cable. So the version 1 ribbon cable was quite large and had a rather large central GRP. So the guys immediately picked up upon that this cable is inherently a lot less flexible and easier to handle than, say, a standard loose tube cable. By the very nature, ribbon cables are quite large. So in Dee Why, we bring in the fibre and we ribbonise them ourselves in our factory. We bring the fibres together in a 12-fibre ribbon and we put a coating around the outside. Those are then stacked together on top of each other inside a buffer tube, and that buffer tube is stranded around a central strength member. So the cable themselves, because of the square nature of a ribbon, it means the buffer tube and then for the cable is quite large and quite difficult to handle. But of course, that does give you the pro is that you can mass fusion splice a ribbon, so you can mass fusion splice 12 fibres together very quickly. So we started off, as I said, with a version 1 product that we inherited from the States. America has been rolling out ribbon architecture for a number of years, over 10 years. So we started off with their product that was tried and tested. But in a bid to improve the flexibility and reduce the size and cross-section of the cable, we've now moved to version 2, which is our current supplier to NBN. So we've reduced the size of the cable. It's now about 80% of the original cross-section. And we've improved the flexibility, the handling, the ability to coil those cables up in the pit, and all those other benefits. We're now moving to a version 3 product, which is here. Again, it's a significant reduction in the cross-section area. And as an added benefit, we're now trying to remove the gel from the tubes that are surrounding the ribbons and replace that with a water-soluble tape. So that means that when the installers are preparing these cables in the field, there won't be any mucky gel to remove from the fibres before they splice. They will be completely dry cables. Again, reducing the speed, reducing the time taken to prepare these cables, and improving the total cost of ownership of the network. So these, again, highlighted on the board. We've got the version 1, version 2, and version 3. You can come and have a look at the reduction in the cross-section and how the cables look like in the flesh. This is also the case with the single tube version cable. We do a 72 and a 144 version in this form. We started off with a version 1. We're now supplying a version 2, again, reduction in the size, improvement in the flexibility. And we're now moving to a version 3 product, which should be available beginning of next year, removing the gel from the tubes and further reducing the size of the cable. Let's have a look at the other products that we've been working on with the NBN. This may look a little bit insignificant. We've developed quite a simple tool to help and assist the installers with preparing the cable in the field. It's quite simple. It's in a bid to enable mid-span jointing. So one of the first things we saw when we were looking at the guides and how they were handling the cable is a lot of times they were cutting the cable and then resplicing a lot of those fibres and only removing a couple of ribbons to splice to another cable. It seemed like quite a difficult process to do, given that the cable is so inflexible. So we developed a simple tool to enable the installers to split and peel away the buffer tubes, like the picture in the top right-hand corner there. And that enables them to gain access to the ribbons and coil them in an enclosure and only cut those ribbons that they need to splice to another cable. So again, trying to remove any unnecessary workmanship from cable jointing. It's quite a simple, cheap tool, easy to make, and it's saving the guys a lot of time in the field. So to cut and resplice a 576 fibre cable, you're looking at probably about a day's work, about 7 to 8 hours. With the aid of this tool, it's brought that installation time down to 3 hours. So what may seem like a simple tool is actually making quite a big impact in terms of cost and speed to deploy. Okay, now to something a little bit more conventional, and to loose tube cable. So our SmartCore cable has been really Prysmian's bread and butter for a number of years now in Australia. It's our standard loose tube cable. We've got a number of buffered elements surrounding a central GRP. And we would compare that to traditional loose tube cables. The SmartCore is a lot smaller, a lot more flexible, and allows a lot more cables to be installed in a given duct. So that was quite revolutionary when we first introduced that. It's quite a long time ago now. We've installed over 140,000 kilometres of the cable over the last 10 years. And it's really the loose tube cable of choice for many of the largest telcos in the region. Just a couple of points to note here. In DY, we have the ability to co-extrude the poly and nylon jackets that surround the cable. So we have a PE sheath underneath and a nylon jacket around the outside. They're co-extruded, so they're bonded together. That means that we can apply the nylon in a very thin radius, and it means that when you coil that cable up in the pits, the nylon isn't going to wrinkle up because it's bonded to the plastic sheath underneath. It also assists to make the cable a little bit smaller and more flexible. The other thing is that it doesn't allow any water to migrate down the cable between the two materials. So when you're looking at a loose tube cable, such as our SmartCore, these are little details that may not be obvious on a data sheet, but in reality, in the field, they're quite advantageous to have a bonded nylon jacket. Okay, so what's next for loose tube cables? The answer is mini loose tube cables. So I guess this is taking on the trend that we saw before with Elaine with flex tube, trying to miniaturise our cable technology, pack more fibre in a given space, highly dense, fibre-dense cables, enabling more fibre to be installed in a given duct. That, in turn, reduces the civil costs and reduces the cost to install a fibre network. So if we look at mini loose tube, this is a radical size reduction compared to, for example, our SmartCore cable. It's a huge reduction in the cross-section area. The cables are a lot more flexible and easy to handle. So I've got a little comparison here on the display board of a 72 and a 144 fibre cables, and you can just see, probably even from where you're sitting, that the sizes are remarkably different between the two. So in New Zealand, they're benefiting from the new mini loose tube cables. They're actually blowing these cables into subducts, to 10mm subducts. So the blowing application is allowing them to install quite long lengths of cable quite quickly. It's a very light cable and easy to handle. So that's one of the applications. But for example, here highlights just how much more fibre you could install in a given duct. We wouldn't advocate that you install mini loose tube cables in this way. I think you'd be asking for trouble. But it's just proving the point that what may look like a small size reduction on a data sheet can translate to some really big differences when it comes to fitting cables into your network. Just a note on mini loose tube, we are now developing this product in DY, so we'll have local manufacture of this product. We're looking at doing that by early next year, and it'll be available in a 72, a 96, and a 144 fibre capacity. Notice what's quite interesting here, with 144, you're still looking at a really quite significant maximum installation tension of 2.5 kilonewtons, so you're it's still quite a rugged cable for the size. You're also not losing any optical fibre performance, even though you're packing that fibre down into smaller and smaller tubes. So again, this touches on what Elaine was talking about the earlier part today, is really this is leveraging off our fibre technology. If we didn't have the fibre that we have available to us, we wouldn't be able to pack fibre together into small tubes like this and offer our customers very highly fibre-dense cables. So you can't have one without the other. So that's something to look out for early next year. Now to something more specifically Australian. As you may know, there's parts of Queensland and rural New South Wales that suffer from reactive soils, what we call black soils. These are heavy clay-based soils that expand and contract in the wet and dry seasons, and they can impart some really extreme forces on any cables that are buried underneath. So how do you answer a call to make a cable rugged enough to withstand those sort of conditions? Well, it's one thing to design a cable and to come up with an idea, but you've really got to put it through its paces in terms of a laboratory testing environment. So when it comes to high-strength cable, this is exactly what we've done. We've actually generated a new test rig called the ACR, Axial Compression Test Rig, which looks to try and recreate some of the forces that the cable may experience in a reactive soil environment. The test is encompassed by two large high-capacity rams that act to compress the cable while it's restricted in its movement, and we can analyse the fibre, the attenuation performance as we put that pressure on the cable. And it's really helped us to really hone the design, the materials, and the method of manufacturing this cable. We've looked at material selection, we looked at process optimisation. It's really no good just whacking a great big heavy-duty sheath around a cable like this and expecting it to pass in these sort of harsh environments. You've really got to look at the technology within the cables, the way the tubes are stranded together, the materials and the thickness of the tubes. These are all really, really important when it comes to making a cable that can withstand these extreme environments. So thanks to the new test rig, the Axial Compression Resistance Test Rig, we've been able to further develop and enhance this cable, and it's led to a new product range termed HSE Extra Core and an enhanced high-strength cable. Okay, another Australian problem is the black rat, and another sort of extreme environment that we try and build a cable that can withstand some extreme punishment from a rat. So black rats in Australia, they're probably one of the more aggressive rats that you can have, and they have a bit of a taste for optical fibre cable, it would seem. Whether it's direct buried and in a duct, where there's rodents, there is the chance that they could start gnawing away at your fibre optic cables and having some rather bad implications for your signals. So again, we came up with a design, and we were sure that this design would probably work, but it's no good having a design without backing it up with some real-life testing. So our friends at Queensland Government have a department there that goes out and catches black rats. I'm glad I'm not involved in that process. They then bring them back to a lab. They put them in a cage. They give them a little bit of food and a little bit of water, but then they put in between our cable a little bit of cheese. And that cheese encourages them to gnaw away at the cable that's in between the cage and the cheese, and therefore helping to put our cable under the rat test, if you like. So this goes on for about 7 days, and after 7 days, a standard smart core cable looks a little bit like that, whereas our armour core cable has withstood the rat test, if you like. So what you'll see there is that the rodent has gnawed away at the outer layers of the cable, but the internal parts, the tubes, are intact. So what is the design? Well, how is the design made up? Okay, so there are different methods you can use to provide a rodent resistant. One is to put a metallic shield around the outside of the cable, but given the soil resistivity problems here in Australia, a non-metallic solution is usually what's required. So here at Prysmian, we've put a GRP armouring around those tubes. There's the glass-reinforced plastic strips. They get stranded around the tubes, and then a further layer of PE and nylon around the outside. So the nylon still gives you the termite protection. The rodents are able to eat through that layer, though. When they get down to the GRP armouring, that's where they stop. And that's what's really providing the cable with the rodent-proof, rodent-resistant layer. Again, as I said, we did the independent testing, so we got the confidence to offer this product to our customers, knowing that it works in a real life scenario. If you can call a cage with cheese a real life scenario. Yeah.
Is it termite resistant or termite proof?
It's termite proof.
And is it rodent resistant or rodent?
That's a good point. That's a good point. So you'll see maybe competitors offering cables that are termed either rodent proof or rodent resistant. Sometimes they get through that wording that to stand up to a test like this, a cable that is rodent proof or rodent resistant might not work quite in the same way. To be able to actually stop a rodent from eating a cable is pretty difficult. The GRP armouring works as glass shards that will enter the rodent's mouth when it's trying to gnaw away at the cable, and it will stop eating in there. As soon as it feels some pain and discomfort, it'll move on to something else. So, yeah, you've got to be careful into what products other competitors are offering, and really look at some of the detail and the testing that they've done to those cables to really understand how rodent-proof or rodent-resistant they are. I don't come back to your point of what is rodent-proof, rodent-resistant. I don't know what the difference between proof and resistant really is. I think you've got to look for a resistant cable, they're resistant to this sort of testing. But yeah, it's those finer details that you've got to really look into when you're making this sort of decision. Another thing to bear in mind, if you are concerned that there may be rodents in the area, it's definitely worth the small incremental increase in cost of the cable to put this extra armouring around it, and then you've got the confidence that it's not going to be gnawed away. Last thing you want is to lay a cable that should be there for 20, 50 years, and then find that it's been eaten by a rodent. So, okay, onto our aerial cables, our all-dielectric self-supporting cables. This is another product line that we've looked to further enhance and develop just recently. Our range of cables, again, like the other cases I've shown, you've got a bit of a problem here in the fact that you need a cable that is strong and able to be installed aerially between poles, but also small and lightweight. So those sort of requirements are sometimes odds to each other. When you're coming to design a cable, you've got to make something that's very small, lightweight, but also very strong. And it's those sort of requirements that we've looked to tackle in our latest range of aerial cables, our SmartSpan range. So the range is from an 80 to 150 metre aerial drop for our short span. We've got a medium span, which is about 350 metre aerial spans, and the long span, 500 metres. So again, we can tailor a product to meet a customer's requirement. If they don't need a large, strong, heavy-duty cable for an 80-metre span, then we can give them something smaller, more flexible, more lightweight. We had a customer that required a cable that was flexible enough to be taken underground and terminated in enclosures, and then brought back up the pole and terminated and continued to be installed aerially as well. So that was a real problem because you had to make a cable that could be flexible enough to be pulled down into a pit just below the pole. So there we looked at optimising the size of the tubes, the method by which we give the cable its strength, and we were able to make a cable that, for a 72 fibre capacity, is 10 millimetres in OD, and strong enough for an 80-metre span. So that's really where you're looking to optimise products, find the best solution that's sort of optimised for the customer's requirements. As you go to larger spans, as you can see, the diameter of the cable has to increase to give you that strength so that the spans are as straight as possible. Okay, now back to, I guess, where we've all started, copper cables. With fibre to the node hitting the headlines more and more, we can't forget about our copper cable. And we've also spent some time recently further enhancing our 100 pair 0.4 copper range. So here we've looked to improve the filling compound that we use inside the cable, and that has led to a smaller, more flexible cable that's also easier to prepare in the field. The filling compound that we've moved to is more like takes the consistency of a hand cream. So you can say we're quite kind to our installers, that we provide hand cream on tap. And that allows also the fibre modules, the copper units rather, to separate more easily, and obviously quicker and easier to prepare the cable in the field. The cable itself has come down in diameter from 19.3 to 17.8. That again may look like a small incremental decrease on a data sheet, but then if you translate that to the reduction in in the bend radius of the cable, in the flexibility of the cable. That can be quite significant for the guys in the field. Certainly, we've trialled this cable out with the installers, and we've been present in the field when they're handling and installing the cable, and the feedback has been really, really quite positive. Quite a stark improvement to the previous design. We've also looked at trying to simplify the colour scheme of the cable as well. We're now looking at having the single copper elements of a pair the same colour. So instead of having them one colour and then the other, both the same colour, which means that they can be more easily identified, and you don't lose the mate of the copper pair, if you like. They're both the same colour. That's been brought about by the advancements in the electronics at either side of the network, meaning that you don't have to distinguish between the two elements of the pair. And again, if that is open to us to explore, and we can bring a cost benefit to our guys in the field that makes it quicker and easier to prepare, then that's something we'll look at. So currently we're trying that alternative colour scheme, and it seems to be going really, really quite well. And no reason why that couldn't take off in the future. Okay, now on to our hybrid cables, and this is a product that's really taken off in New Zealand. We've got my colleague Matteo here, who's based in New Zealand. He's going to talk us through a little bit about the hybrid OptiCat cable.
Okay, so this is an example of the thinking out of the box that the Kiwis do usually. This is a product that they were already using, but it was supplied by a competitor of us. At a certain point, they came to us and they said, we want to have a smaller version of the hybrid cable because it would be easier to install it. So what we did is actually taking advantage of our optical fibers, which are the bend-bright excess, and allows us to be more compact and it's not affected by macro and micro bending, as Alain explained before, just to shrink the dimension of the cable. And instead of, and we could give them a cable which is a Cat5 cable plus two optical units, one optical unit containing two optical fibers. And this is the standard product for Chorus, which is installed basically everywhere where they bring their fibers. Let's see how they use it. So the idea is actually to use it both in the brown field or in the green field. Let's go a little bit better into details. So imagine that in your house, when you bring the fibers and you remove the copper, here you're missing a link, and this link doesn't feed anymore the former network inside the house, which has been used forever. It works, and why do you want to get rid of it? Why do you want to install new cables? What you do is actually, what you need to do to reuse it is to plug in at the beginning of the network itself, because all the, in this case, it's just a burglar alarm control, but it can be something like, for elder people, the controls for the health. So they need to be plugged in at the beginning of the copper network. And here is where you take advantage of OptiCat 5e. You just connect your termination box with an hybrid cable. So you don't just plug in the fiber inside your ONT, but you plug back the copper inside your OptiCat 5e. This sends the signal back to the beginning of the network, just a matter of a small connection here, and everything will work. So it's actually a very good idea. One of the things that we were thinking to offer is actually something like the pizza box. We will explain better the idea of the pizza box later. Is actually just a pre-terminated cable. So imagine that you have your termination box where the cable is already terminated, and you just need to deploy the cable to the beginning of the network. That would be very easy and very quick. Another situation where Chorus use the OptiCat 5e cable is when they have to take advantage of a Cat5 twisted pair to send the signal of the VDSL or whatever is that from the ETP, where usually they lay the VDSL filter, up to the center of the star of distribution of the network inside the house. So basically this yellow link that in this case is very short, but it can be, you know, this box here can be all over the place in the house. There is no a fixed position. Usually you would put it in the lounge because it would be closer to your TV set. And so this link is usually made with OptiCat 5e because it's future-proofed. I mean, the day when the fiber will be connected, the link with the optical fibers will be already there. Just to show you that we have plenty of these solutions across the world. For example, this comes from Germany, and it's we call it OptiCat 6e. So basically, if Cat 5 is not sufficient for you, you want to go over that, you can have a Cat 6 cable, which has a shape of a shotgun, because we know that if you don't plug the twisted pairs in the connector immediately after they leave the separator in the center of the cable, you lose, after a few millimeters, you lose completely the advantages of a Cat 6 cable. That's why we designed the cable, which is a shotgun. And you have an optical unit and a copper unit. So the optical unit can be separated, can be routed to wherever you want, and you have the copper terminated inside the connector immediately. And this is all.